Morning, guys. So today we are doing volume, and the objective of this module is to give you guys again some basic foundation when it comes to geometry that is relevant to you guys as designers. So, in terms of volume, why is it important to you guys as designers? You might find that you're making products which you will need to you're making products that will need some form of packaging, and you need to figure out how much space your products need to be packaged, to be packed for shipping or for whatever reason. Another way to look at it would be a product itself that you make can be designed in such a way that it is meant to be a container, and you need to figure out how much of the contents that container can take. That is the objective of, or the meaning of, volume and relevance, with its relevance to you guys. Let's get to it. So, a volume, by definition, is a measure of the space inside the solid object. What it means is that to figure that out or to calculate it, you have to measure it in 3 dimensions. 3 dimensions meaning figures such as this one's on the right. And then the units of a volume would be cube length or units cube. So we saw the units of area as units squared. The units of volume would be units cubed. So that's very important when you are giving answers and calculating all these volumes. So notice that the 3 dimensional objects are not flat. They have 3 measures. They have 3 measurements: length, width, and height. Those are what you need to calculate volume, and we will look at this in a bit more detail just now. So some definition: a rectangular prism. It is important to know that in this context, and it means a solid figure that has 6 faces that are all rectangles, and the opposite faces are congruent and parallel, like this box. And notice as we go along that this links up with the terminology that we introduced already around geometry, about parallel lines and right angles and triangles and all that. So some of them we use that terminology here, which will make it easy for you guys to understand this. So when we're calculating volume, we'll be talking a lot about prisms. So a cube is a solid figure that has 6 faces as well, that are all squares, as we've seen in the previous modules as well. All these faces are congruent and parallel. So in a way, you can look at the cube as more of a rectangular prism, except that all the sides are equal as squares. These are the shapes that we go into look into a bit more when we calculate volume. So then how do we calculate volume? Since we now know that the volume is measured in cubic units, which now is saying cubic centimeters. also called centimeter cubed. It's just another way of representing it or saying it, but it still means the same thing as units cubed. So since we know that, we can use the standard way of figuring out how much space a solid object takes by looking at a cube which measures 1 centimeter in all directions, because the definition says volume is measured in cubic centimeters. So this being now the basic approach that you can use to calculate as to calculate volume, or simply by using the measurements here to calculate. But so there's two ways of doing it. Take the cube, try and fit it in a solid object and see how much space it takes, how many cubes you can fit in that place, in that object, or simply just use the numbers to calculate the volume. So as we've seen again, volume is measured in cubic centimeters, or again it's measured in 1 unit, 1 height, 1 unit, 1 length, 1 unit, 1 width. All this means the same thing. This is the same thing as that. It's just that you are trying to define it as what it means in a different way, because we can understand it when certain terminology is used. So overall, the formula for calculating volume would be the base multiplied by height. The base, that means you have to calculate first the base of whatever object that you are given, and then when you calculate the area of the base, it will be length times width. Then after you do that, you simply just multiply it by height. But there's various ways of doing this, as we will see just now. So let's consider a cuboid, such as this one on the right. We first have to calculate the area of the base, as we've just seen, which will be this one here. And then we can actually take it out in a way that we saw in the previous modules. We calculated areas of rectangles, areas of squares, triangles, and all that. So this, if you take it out of that shape, it's just this. So calculating the area of that first. So one way is multiply 10 by 3, or since we are talking about cuboids and we're talking about volume measured in cubic centimeters, for consistency, let's say how many cubes that we just saw as the basic measure of volume can go into this area here. So you literally have to draw or slot, if it's a physical cube of 1 centimeter, 1 centimeter, and 1 centimeter by height, how many fit into there, then you count them. That's the area of that. So it's another way, as opposed to multiplying 10 by 3. They give you the same answer. So area of the rectangle, length times breadth, as we know, and then you get it in square units, because it's the area of the rectangle, not a volume. So this, to get the area of to get the volume now, having calculated the base, you use the approach of using the cubes to try and slot them into the cube to figure out how many can go into that, because volume is a measure of how much an object can take. So having calculated that, in the top one here you have 30 cubes that can fit in there. Cool. So then let's go into volume. How many cubes can you fit into this cuboid? You have the first layer that you calculated. All you do is keep adding cubes until you get to the top. Alternatively, this that you got, which is 30 now, you multiply by height to follow the formula. So if we take the approach of putting the cubes in the cuboid, you will have another layer of 30, which will be at the height of 2 centimeters, then another layer at the height of 3 centimeters of this 4, until you get to another layer. Sorry, I pressed the reverse button. Until you get to another layer, the fourth of this height. Then how many do you have in there? So volume will be 120. You can put in 120 cubes in that cuboid. So we have figured out now that the volume is 120 centimeter cube or cubic centimeter. Because now we realize this, we can use the same approach to calculate the volume of many other three-dimensional objects. Applying the formula that we saw, that the volume would be the length by the breadth by the height, in short, LBH. So try and use this for practice, and this may or may not be in the next worksheet, which will go up today and again will be due on Sunday. So practice on this and see if you can calculate volume of these cuboids.